Go ahead and if you haven't yet, let's test that you can share screen.
Sure, sure. Can you see it?
Yep, it looks perfect.
Okay, that's good then.
Yep, looks really nice. Okay, so I'm gonna have a screen for the beginning, and then I'll stop sharing,
Okay,
and you can go on and share after that. It doesn't the way it's set up, it's easier to stop. Yeah, so
okay.
I will let people arrive right at the beginning. I'll welcome people and then wait till a minute or two after the hour for people to join and then turn it over to you.
Sure, sure. Thanks.
Okay, cool. Let me get my first screen started and I will be right there.
Okay.
Well, I think we're going to wait for a minute or two. I expect there to be some other folks. I don't know the total registration numbers, but I know that many people end up watching this in a recorded version. So this is Diana Sinton. Welcome, everyone. We are here for today's virtual consulting office. Two of the students associated with iGuide, Run-Shu Tian and Patrick Zhu from University of Illinois Urbana-Champaign, are going to share their research with us. We'll get started in just a minute. As a reminder, we're using regular Zoom meetings for this session, obviously, so please keep your own microphone muted. We will have time for questions and discussion at the end. We're going to wait just another minute, see if anyone else joins us. As a reminder, I've put up on the screen also the session that we'll have next week, talking about the ways that iGuide's convergence curriculum is incorporating AI into both its development and its content itself, its evaluation and its content. Okay, Run-Shu, why don't we can go ahead and get started. I will stop sharing, not scaring. I will stop sharing.
Sure.
And
Thank you, Diana, for the great introduction.
you are welcome to share yourself. There you go.
Sure. So basically, today we are presenting our work called TaxoCite, where this work is completed by me and Patrick and the iGuide team at UIUC. So in this project, we are trying to do some kind of citation intent analysis or classification for the scientific literature. And we have submitted the paper to KDD 26, and hopefully we can get some good results. So today we'll be talking about the motivation and the problem setting, and also about the benchmark we constructed to facilitate our analysis. And we will also talk about our methodology framework, our experiments, and finally the analysis and takeaways. So basically, the task here we try to solve is that we try to answer the question that why one paper cite another. Like here, you may see that here is a little chunk of the scientific paper where we adopt PLM, which refers to Portraying Language Model from citation A as text encoder, and compared with QA baseline such as citation B. So basically, the task or the thing we want to do is that we want to identify what is the intent of such an intention. Like, is it offering some kind of background, or is it citing another paper as the method, or is it citing another paper to do some comparison on the results? So we think this task is important because there are many different downstream applications that can be extremely useful in the practical implementation. For example, we can use those citation intent to build a citation graph, and we can also use the citation intent to help us do the document retrieval, basically the same the researchers are doing every day on the Google research, and we can also use those kind of intentions to do scientific question answering and also for scientific writing. And there is some existing methods, like previous methods, do those kind of analysis on the flat and very coarse label space. As you can see here, for example, they only have 3 different categories, like background, method, and result comparison. And also, those kind of intent labels, they are topic agnostic. That is to say, they only have very general categories that are not related to the topic of this paper. For example, for some different metrics, we can have information retrieval metrics and RAG metrics. So they are both labeled as metrics, but actually they can have different topics. So these are the three key limitations we identified for the prior work. The first is, as I just mentioned, they are too coarse-grained. For example, they only have three categories for those all very diverse citation intents, and their label space is topic agnostic, and also their label space is unstructured. That is going to say they only have a flat label space like this one. And our proposal is we want to make the label space fine-grained and topic related and also structured. That is to say we the labels, they are related in a structured ways. For example, in the tree structure, they have relations like siblings or parent-child relationships, so something like this. So we propose to solve this task, we propose this hierarchical label space. So we are going to do the analysis on the hierarchical space of the fine-grained labels over two complementary taxonomies. One is the general citation intents like the previous ones, another is on the field topics. So our proposal is going to perform better than the previous ones for three different reasons. And actually, I give three different cases to better demonstrate how we can better analysis the citation intent with our setting. So the first, for example, we get some literature like for retriever components, we adopt model from citation A, optimize it with algorithm in citation B, and train the model on dataset released by citation C. So if our label space is coarse-grained, then these three different citations are all going to fall on this method type. But they're quite different, and if you all label them as method, we're not going to distinguish them. However, with a fine-grained label space like this one, we further develop this method into nodes like model adoption, optimization algorithm, and training data. So with the fine-grained label space, we can actually distinguish the differences between these three citations. And the second one is about the topic agnostic versus topic aware. So for example, here we have some literature like we evaluate the text retrieval with retrieval metrics following a certain paper and integrate the RAG system with generation metrics following another citation. So if we do not have this topic related information, we are also going to identify them into the same classes, like they are both metrics. However, they actually belong to different topics. So if we can distinguish them, it will definitely be more informative. And our solution is we also provide a topic-aware taxonomy like this one. So with this taxonomy, with this classification structure, you can find that we actually have two different classes. One is text retrieval and another is RAG. And if we can successfully classify citation E into text retrieval and classify citation F into RAG, then we can also make a distinction between these two citations. And finally, the last scenario would be the unstructured versus structured. For example, if we get some text like we utilize multi-architecture citation G as the backbone of our method, and we evaluate our system with metrics from citation H and datasets from citation I. So if we do not have those kind of structure, we will treat these three labels equally different. However, by human knowledge, we can know that actually metrics and benchmarks, they are somewhat closer because they are all related to the evaluation, and the distance between them to the architecture are somehow very large. However, if we can have this structured classification system, we can actually find that indeed the metrics are benchmarks, they are siblings, they are both the child under the evaluation node. However, the architecture, on the other hand, are somehow far away from these two existing labels. So that's why with our hierarchical topic-enriched citation intent classification setting, we can make this citation intent analysis task much more informative. Yeah. So to sum up, our proposal is we want to enrich the previous classification label space into two structured fine-grained taxonomy. One is on general intent, like methods or background or methodology, something like that. Another is on topic. For example, we have different topic and subtopics from computer science, geospatial information science, and chemistry. And to facilitate such analysis, we actually annotate a benchmark and also provide a non-trivial LM-based pipeline. And also we did some experiment to show that actually LMs with our new setting and new method can do a very good job in this citation intent classification process. So first, I want to introduce our benchmark. We call it HiToBench, which means hierarchical topic-enriched benchmark for the citation intent analysis. And we collect 100 papers from 3 domains, from computer science, geospatial information science, and also chemistry. And we collect in total 5,160 different citation instances. So we collect different papers from different domains, from diverse domains, where they have different characteristics. For example, in the computer science domain, actually those citations are very method-centric, and they usually refer to different models, baselines, and benchmarks. And for GIS domain, we actually observe that those citations, they more refer to the spatial analysis protocols and also quite method-centric. And for the chemistries, all the citations somehow go to the experiments and the mechanisms and also the special terminologies. So this is the annotation pipeline we constructed for the benchmark construction. So first, we actually recruit some human experts to help us collect the PDFs from the GIS, chemistry, and CS domain. And then we use the language model to do some parsing and convert the PDF files to the structured markdown files so that they can be directly processed by the language models. And then we annotate each citations with the intent and topic labels from both taxonomies, and of course with human experts. And then we iteratively refine the guidelines and also the annotated labels. And we also conduct some cross-annotated review to ensure that we have a very high inter-annotator agreement score, so that we can make sure we have constructed a high-quality benchmark for the following evaluation. And so this is the overview of our method. It seems a bit complicated, but actually the philosophy is quite simple. So the first part is that we want when we do the prediction, we want there to have some kind of interaction between the topic and intents. And our belief is the prediction of the intent can help the prediction of topic and vice versa. So here we actually adopt a bidirectional process where we first use the forward pass, that is, given some citations, we let the LMs to predict their topic or intent category. And we also have a backward process where we, given some categories, we ask the LMs to pick out the citations that satisfy the definition of these categories. And with these two processes, we can actually get 2 sets of answers from 2 directions. And based on the difference of these answers, we can actually calculate the consistency between these 2 predictions. And based on this consistency, we can tell that which cases are easy cases, which cases are much harder. So once we identify those cases that are much harder, we can use we can allocate more computational resources to further make the prediction of those hard cases more robust. So that's when we adopt this majority voting refinement, where we let the LM predict the category or the intent of one citation for several different times with different random seeds, and naturally with different reasoning paths. So based on those kind of self-consistency based verification, then we can get a much higher score on the higher cases. And for the easy case, since we get the prediction results the same for the 2 directions, they are naturally of very high quality. And then we also conduct some experiments to further analysis the current performance of the language models and also the performance of our own method. Maybe Patrick can give some introduction on these sections.
Yeah, so basically for the experiments, we try to implement some of the traditional used agent-based methods like zero-shot, COT, and reflections. And for the classification, there are two metrics that we are used for evaluation, which one of them are evaluated each dimension of the classification. And we also did further analysis to see whether our methods can be useful for different backbone models. So for next slides, I can share the main performance table. So we typically use the two major backbone model, GPT-5 Nano and GPT-5 Mini, to see the performance across both the CS, GIS, and the chemistry domains. So as you can see here, the TaxoCite consistently outperforms that all those like general agent-based LM or LM-based methods. And then another key findings is we actually find that for the domain topic classification is actually harder than the intent classification. That typically because of for the topic classification, it actually requires the model to have some domain knowledge. Otherwise, it's hard to say whether a citation is associated with this topic or not. Another finding is for this general large language model prompting-based method, like the train of thought and reflection, provide limited or inconsistent gains versus the zero-shot one. And especially for the smaller language model like GPT-5 Nano, the COT and reflections not always provide the gains, but sometimes will hurt the performance. For the TaxoCite, we find that it outperforms all the baselines across different like backbones and domains. And then we can see the larger gains on the domain topic dimension. That because it's actually harder. So once we detect those like imperfect citation, we try to refine it. The performance gain will be more impressive than the general intent classification. And then another finding is we find for the general intent classification, since we know based on the context, we probably can guess what the intent is used for this citation. So it does not require a very sophisticated model to do these kind of things. But for the topic classification, obviously the circumstances can be more complex. We also did ablation studies, try to see whether each of the components also contribute to the final performance. We find that removing any component actually reduces the performance on both the intent classification and the topic classification, which means the full pipeline benefits from the complementary signals across different components. We also find that the topic intent interaction has the largest single component impact on the GIS. The bidirectional consistency actually can lead to a clear job on both dimensions, because if we kick out those consistency check, then we just typically let our model to do the refinement for all the classification. Is just similar to the self-reflection, which in our main experiments already show that it's not consistently provide a reliable signal to help the model improve its classification results. And we also find that the majority voting shows the largest degradation on harder domain topic settings. So majority voting is a self-consistency based method, which we want the model to improve its path set 1 if it has a larger path set k scores. Yeah. We also did another like stage-wise performance analysis to further analyze what are the performance gain across different domains. So we actually find that for the initial like prediction, the topic intent interaction produces a structured intermediate output via this dual process. And if we take a look at the consistency check, the inconsistent ones actually have a larger incorrect classification results, which means the consistent check can provide a very reliable source for the error detecting, and it also means that this unsupervised signal can be used for improving large language models its prediction. And you can see after the majority voting, the target refinement requires many previously incorrect instances from the 1,500-ish to the 2,400-ish. To further evaluate our method robustness, so we try to use different families of large language models. And based on our experiments on the subset of both three domains, we actually find that the performance gains persist across different models, even we change the model family. And the stronger gains on the open models, especially the smaller one. So the method is not like tailored to a specific model family. It actually generates well to different backbone models. And we also find that the improvements are particularly pronounced for the domain topic prediction, which is consistent with our initial main results. So as a conclusion, we position our paper have the following takeaways and contributions. First, we introduce a new task, the hierarchical topic-enriched citation intent classification, that obviously provides a richer information compared with traditional flat and intent-only classification. We also provide a HiToBench, which contains 5,000-ish human-annotated instances across 3 different domains. And this benchmark can be further used for the citation analysis. We provide a test time scaling pipeline for the large language model, which can be used for the topic intent interaction, which uses topic intent interaction, bidirectional consistency, and the majority voting to improve the model's performance on our task. We actually find that the TaxoCite consistently outperforms all the baselines, which shows it can be a promising unsupervised method used for the downstream applications. And we think in the future, the more advanced citation analysis can be done towards the fine-grained structure and topic-aware understanding of like how we use those citations and how those citations can use to improve the quality of the paper.
Thank you, Patrick. So I think overall we'll give a presentation on our recent work. And we're expecting some questions, although we don't really have a lot of audience here today. But I think it's fine.
Yeah, no, I know it's helpful because I know you'll be asked to do a lot of presentations on this to have these slides organized.
Sure,
It's a really good, clear presentation.
Thank you.
Anyone have a question? And maybe I would just kick off discussion for a moment to say, from a computer science perspective, when you started working on this project, does it seem like tell me what gets you excited about this? Is it kind of the ways to advance research across these different domains, or to make the types of sources of data that we haven't been able to use effectively more, or is it more of the computer science, the work with large language models, or like tell me where you get excited about the motivations for this?
Sure. So for the motivation side, actually this task, let me go back to the previous slides. I think we can talk about this with this figure. So actually this citation intent analysis task, it has been proposed for like more than 15 years. And at the time, people are using techniques that are somewhat classical to the nowadays. And no one has systematically applied the large language models or explored the potential of large language models on this task. So I think the biggest excitement or motivation for me is that I want to see how the very novel, the state-of-the-art technique or methodology can be applied to this old task, and how can this old task be further extended to the standard of more contemporary granularities of the information. So basically, I want to apply a new skill a new method to old task, and I want to see
Mhm.
what will happen. And that's basically the motivation.
How do you think this will get ultimately? I know you had some ideas for next steps and things, but in the big picture, like in another 15 years, how will this have been incorporated? And this and the things it leads to, how will this have been incorporated into the use of citations, period?
Okay, so the task will not be an independent product like people will like have a website and to ask about
Mm-hmm.
this. It is going to be some process of some module of the very powerful AI systems. Actually, they have been a part of them today. So I think most of you may have used the deep research feature of the chatbots. And maybe you have also tried the academic AI writing assistant, which will suggest you some help you find, for example, the relevant papers. So actually, this citation intent analysis is going to help you find those relevant papers. That may be the most practical current use. So you can
Mm-hmm.
imagine that if a language model or some kind of AI, it only knows how to use the search engine. So the chances for them to get a very complete list of the relevant literature can be very slim because you can imagine how we human do the literature search. We actually don't use the search engine all the time. Once we get a very relevant paper, then we just look at which papers this relevant paper cites. And then
Mm-hmm.
from that list, we can actually just grab a very high quality list of the relevant papers. So that's where I think our citation intent analysis can be applied because you cannot just grab all the papers this relevant paper cited as the further relevant papers. You need to find those citations which are relevant to your intent. So that is to say, you should first judge the intent of the citations one paper provide. So you can make a judgment or assessment of whether this intention is aligned with my intention, and you filter out those unaligned ones, and you only keep those intents with the aligned intention. So for that part is where our method is going to be very helpful. Yeah.
Yeah. Super interesting. So when is the KDD conference?
I think we submit the paper in early February, and there's going to be a rebuttal discussion phase in late March or something. And I think our discussion will be very helpful for our further rebuttal. Like just you mentioned, what is the significance? What is the motivation for this work?
Right. Yeah. Well done. It's really nice to hear about this.
Thank you, Diana.
Yeah. Okay. Well, thank you very much for giving some time today to document this. And we're glad that we'll have the recording up to share with others, and it'll be distributed to a lot of relevant specific audiences looking at research into citation work. Thank you everyone again for coming. Stay tuned to this channel. We'll have other virtual consulting offices coming up soon.
Thank you, Diana, for organizing this.
All right.
Yeah, it's really
Thanks.
exciting to have you here.
Yeah, and keep paying attention to things on iGuide. We have a lot of exciting things happening over the next 6 months. So we will sign off now, and I think the recording will get eventually, once everyone leaves, recording will stop. All right,
Sure. Thank you.
thanks. Bye-bye.
Bye.